Welcome to our bin picking video for MENG 485, and what you're seeing here is a 2D version of a bin picker, and what we are picking today are ping pong balls. Some are black, some are white, and you can see here we have a series of trays that come down a conveyor belt, and on each of the trays there are a series of rings that we place the balls into. Inside each ring is a particular symbol, and we have a symbol for white balls and a symbol for black balls. And so what's going to happen here in the basic program is we fill the trays by selecting the correct balls out of the bins, and then once the tray is full we pick it up and place it on the left end of the back conveyor belt for palletization. So this is a pretty straightforward vision project. As you can see, we have a camera mounted on the robot arm on a little rail there. And so what happens is the robot first moves the camera over the top of the tray, takes a single picture, and that lets it identify which color and number of balls it needs to pick up. And then for each ball it hovers the camera over the bin, takes a picture, and then decides which ball it wants to pick up, picks it up using the vacuum cup, and then comes back and places it into the correct location in the tray. So this is good and all, but in many industrial applications, you're not going to have a bin that has a single layer of parts in it. And those parts may not all be nice, round, even ping pong balls. And so what we wanted to do with this system is to have it pick objects out of a 3D filled bin, which means that we would have to be able to handle multiple layers of balls. And so we set out to do this as our project. We didn't quite get there, but what we want to do today is to show you what we have done to this point, and then talk you through what we've done on the MATLAB side, which is what we're using to do the 3D, and then we'll actually give you a little demo. So for the 3D aspect, we are using a Kinect sensor from Microsoft. We did unmount the sensor for the purposes of this video, but you will see it in photographs and in our lab report. So now we're going to take a look at the MATLAB code in action, and for this demonstration we will be doing a calibration with 3 balls in a triangular shape, and we have already taken a picture on the Finute camera and we have those coordinates available to us. So first we're going to run Translation Finder, and this maps the Kinect image coordinates and the Finute coordinates into the Kinect depth coordinate system. And let's take a look at this result. So you can see this is a Kinect image, and the red crosshairs tell us where the center of each ball is according to the image sensor, which it's good that we have the crosshairs directly over the balls. And then we have 3 additional crosshairs. The cyan crosshair indicates where we originally said the Finute coordinates were. And I gotta get my colors correct here, the green crosshairs indicate where the Finute coordinates are after we ran it through our translation algorithm. And the yellow crosshairs indicate where the centers of each ball were translated from the Kinect image coordinate system into the Kinect depth system. So you can see the green, cyan, and yellow crosshairs are all pretty close, which is a good indicator that our calibration is going to be successful. So now we're actually going to run the depth finder program, and this is what we would use to find the heights of each of the balls in the bin. And you'll see here that we have again the Kinect image, and we have overlaid a red circle on each of the balls at the location of them according to the image sensor. Again, good thing that the image sensor knows where the balls are. The blue circle is where the ball locations have been translated into the depth coordinate system. And then the white crosshairs are where the Fnuk coordinates were mapped into the depth system. So again, it's a good thing that the white crosshairs overlap into the blue circles. This is what we expect to see. And one of the correction factors that we did put into the code is that if the crosshair lands anywhere within the blue circle, we adjust the coordinates to the center of the circle, and that allows us to not have to rely so much on the strength of the vacuum picking up the ball. If we have any margin of error, we can just correct that location and do the pick as close to the center of the ball as possible. So now that we've walked through the calibration and we've shown that the calibrated balls can be found by the depth finder, we're going to take a look at what happens when we add a ball that was not part of the original calibration into the system. So right now off camera, we are adding another ball to the conveyor, and we are taking another picture on the Fnuk. And so now we are ready to see what this looks like from MATLAB. And you can see here we have 4 balls that we found. And again, the red circles, exactly where we want them to be. The blue circles are where those red circles have been translated to the depth system. And you can see here, only 3 of the 4 Fnuk coordinates were successfully translated back into the depth system, and it is the 3 balls that were originally part of the calibration here. And you can see this is the last crosshair here, and it seems to be mirrored across some axis here, and whereas this is where the Fnuk coordinate is, this is where the image to depth coordinate translation says the ball should be. So this is the best result we've been able to obtain from the MATLAB. We're still trying to figure out exactly what's happened here, but we did want to show you the progress that we've made on this to this point.